Hey everyone, I'm Sushant and welcome to the channel. If you've ever opened your NCERT Class 9 Science textbook to the chapter on motion and felt a little overwhelmed by all the new words, you are in exactly the right place. Think of this video as your personal, comprehensive glossary, a deep dive into all the essential keywords you need to not just pass your exams, but to truly get a handle on the physics of how things move. We're going to break down everything, from the most basic concepts to the equations that tie it all together. Now, I know learning a bunch of new terms can be tough, which is why I've made sure to include subtitles right at the bottom of the screen. You can follow along, pause when you need to, and really let these definitions sink in. My goal here is to build your confidence. By the end of this video, you'll have a solid foundation in the vocabulary of motion, which is, and I can't stress this enough, the absolute key to understanding the more complex ideas we'll tackle later on. So, grab your notebook, get ready to focus, and let's start this journey together. We're going to transform this long list of words from something intimidating into a powerful toolkit for your scientific exploration. We'll make sure you can walk into your next physics class or exam feeling prepared and ready to talk about motion like a pro. Let's get started. Motion is simply an object's change in position over time. An object is at rest when its position doesn't change. Distance is the total length of the path an object travels. Displacement is the shortest straight line path from start to finish. Speed tells us how fast an object is moving, basically. Velocity is speed, but with a specific direction mentioned. Simple. Acceleration is the rate at which your velocity changes over time. Uniform motion means moving at a constant speed, no changes. Non-uniform motion involves changes in speed or direction or both. So, motion is always described relative to a stationary reference point. That means, how we see something move really depends on what we're comparing it to. This is just a fancy term for motion in a straight line. Basically, if something moves straight ahead without turning, that's rectilinear motion. Circular motion is when an object moves along a circular path. It's like whenever something goes around in a circle, that's circular motion. So periodic motion is basically motion that repeats itself at regular time intervals. Oscillatory motion, well, that's a to and fro movement around a central position. Rotational motion is when an object spins around its own axis. So, translational motion is when an object moves from one point to another. It's actually pretty simple when you think about it. The rate of motion is just another way to describe speed. Basically, it's how fast something is moving. Average speed is the total distance covered divided by the total time. It's a handy way to figure out how fast something was moving overall, even if the speed changed along the way. Instantaneous speed is the speed at one specific moment in time. Uniform velocity means constant speed in a perfectly straight line. This occurs when either the speed or the direction changes. So, acceleration due to gravity is, actually the constant acceleration that objects experience when they're falling freely towards the Earth. A distance time graph, well, it basically plots how far an object has traveled against the amount of time that's passed. And you know, a velocity time graph shows us how an object's velocity changes over a period of time. So, the slope shows speed on a distance time graph and acceleration otherwise. It's actually a really useful concept when you're trying to understand how fast something is moving or how quickly it's speeding up. The area under a velocity time graph represents the object's displacement. Basically, if you figure out that area, you know how far the object has traveled. This equation, v equals u plus at, connects final velocity to initial velocity and acceleration. It's one of those formulas you'll use a lot, so it's definitely worth remembering. Alright, so this equation helps you calculate displacement when you know the time and acceleration. It's super useful whenever you need to figure out how far something has moved, given its initial velocity, acceleration, and the time it's been moving. Now, use this one to find the final velocity, even if you don't know the time. It's actually pretty handy when you just have the displacement and acceleration, and you want to know how fast something is going at the end. So, initial velocity, or u, is simply the velocity of an object at the very start. Like, before anything really happens, that's your starting speed. So, final velocity is the velocity of an object at the end. Again, acceleration is just the rate of change of velocity. Time is basically the duration over which the motion is being observed. So, remember, displacement is actually the shortest distance between the start and end points. This is the inward force that keeps an object moving in a circular path or in circular motion. Angular velocity, well, it measures how fast an object rotates or revolves. So, tangential velocity is basically the straight line speed at the edge of the circle. The radius, well, that's just the distance from the center of the circle to its edge. Freefall means motion that's influenced only by the force of gravity. Alright, so projectile motion is basically the curved path of an object that's thrown into the air. It's a really cool concept because, you know, it shows how gravity and motion work together. Now let's talk about Newton's laws of motion. These three laws are honestly the foundation of classical mechanics. Pretty simple but super powerful. Next up is kinematics. Kinematics is the study of motion without considering its causes. So, we just focus on how things move, not why. And there you have it. A whirlwind tour of every major keyword from the motion chapter. We covered a lot of ground, from distance and displacement all the way to kinematics and Newton's laws. It might seem like a lot right now, but I promise, the more you engage with these terms, the more they become second nature. I really encourage you to come back to this video, maybe once a week, and just review these definitions. Repetition is a superpower when it comes to learning science. Think of this vocabulary as the building blocks. Now that you have them, you can start constructing a much deeper understanding of the world around you. If you're ready to take the next step, be sure to check out my other videos where we use these terms to create concept maps and solve numerical problems from the NCERT textbook. We'll connect these dots in a way that makes everything click. It's one thing to know the words, it's another to see them in action. Thank you so much for watching and for investing this time in your learning. I hope this guide was helpful and made the chapter a little less scary. Keep that curiosity alive, keep asking questions, and I wish you the absolute best of luck in your studies. I'll see you in the next video.